Hey everyone, in this video I am going to explain to you what environment maps are and how you can use them in your React Tree Fiber or Three.js project. And we are also going to runtime generate environment maps in React Tree Fiber and use those to reflect our own scene on objects in that scene. So an environment map is just either one big texture or a set of textures that together display a 360 degrees environment, and it is mainly used for two things. So first, it is used to display a distant environment that is surrounding the scene, and in this case you can think of, for example, mountains in the background. And second, it's used to give reflective objects something to reflect. If you've seen my previous videos, you'll see that so far we've only reflected light, but in this case we're also going to reflect other things such as trees or mountains, as mentioned before. Now, before we dive into the code, let's first download an HDRI that we are going to use as our environment map. I downloaded mine from Polyhaven, which offers a bunch of free-to-use assets, and I placed it into my public folder so that we can access it from our code. Now, to start coding, I copied over the base code that I use for all my videos, which you can download from my GitHub, and I will leave a link down below in the description. So you can go there and code along, and while you're going there, don't forget to like and subscribe in the meantime so that you don't miss any future videos. Okay, now first of all, if we want to reflect our environment map on an object, we're gonna need a reflective object. So for that, we're gonna start with adding a reflective sphere to our scene, which we can create right here above. And what this is going to do, it's going to return a basic sphere from React Tree drei with a mesh standard material so that we can tweak some of the properties in there. Now, a sphere requires some arguments, and we're going to set the radius, we're going to set the width segments and the height segments. So the radius is going to be 1. It's going to be quite an detailed sphere with 265 width and height segments. And for the mesh standard material, we are going to make the properties tweakable using leva. So let's get some tweakable properties from the use controls hook, which we import from leva. And first of all, we're going to make the roughness of that material tweakable. And we're going to give it a default value of 0.1 with a minimum of 0 and a maximum of 1. And next to the roughness, we're also going to have a metalness, which will basically be the same, except that the standard value will be 1, which means that our sphere is going to be very metallic and not so rough. So that is going to reflect most of the environment map and other objects in our scene. Now, this tweakable properties will return this will be of a type object with a roughness and a metalness properties, and we can spread that out right here so that we send them to the mesh standard material. And as you will see, there's a sphere now which is reflecting. We can change the metalness and we can change the roughness right here to make it less or more reflective. And you can also see that this looks quite unrealistic since there's only some light, and yeah, that's all. Now, there are several ways to import an environment map or to use it in React Tree Fiber, but we're gonna start with a simple import of the HDR and passing it to the mesh standard material. So let's set an env map using the use environment hook from React Tree drei. And in there we have to pass an object, specify the files property. In our case, it's going to be modern buildings. And I called it hdr.hdr. Now save this and set the env map of the mesh standard material to this map that we just created. And there we go. This is already a completely different look. And you can see that next to the light that we have in our scene, you can see the entire environment. But one thing is a bit off, and that is that the actual environment of our scene is not showing anything. It's just white. So the reflection doesn't make much sense because we don't actually see that environment. And we can fix that as well. And the most easy way is to use the environment component. But in that case, we're going to add that to our 3 scene and not specifically to the reflective sphere, because the environment component will actually apply the environment map to all the objects that we have in our scene. So let's specify that here and then set the map to the env map. And we're gonna have to move that over from there to here as well and remove it from our reflective sphere. Now if we save that, you'll see that we have the same result. But the great part about this environment component is that now if we add another object, it will have the same reflection. And another thing is that we can add a background property, which will also add a background. And now the reflection actually makes sense. So if we would look, for example, at this pole and we turn around, you'll see that the pole is there. Now the background property is false by default and we set it to true by specifying it here. But it's also possible to set it to only in case you want the background to have an environment map, but not have it displayed on any of your objects. Now, in some cases, you might not have an HDR file, but you might have 6 separate textures, which are displaying 6 sides of the environment. So the way it's doing that is it's basically creating a cube, which on each side has a camera, which is recording like 1/6 of the entire environment. And the most easy way to show that is by giving you an example. So if you would search for HDR to cubemap, we can convert our HDR to a cubemap. And we can actually see that as well. So if we go to the cubemap view, you can see how it basically contains 6 separate textures. So if you would cut a line here and cut lines right here, you would get 6 square textures that all contain basically 1/6 of the entire environment. So let's save it, and here you can also see that you can split it up in those 6 textures. And don't forget to increase the piece resolution as well. Hit save, and there you go. Now I moved those files over to my public modern buildings folder next to the HDR. And now we can start using those instead of the HDR itself. So we're not going to specify the files anymore in this case, but we're only going to specify the path. The path in this case will be /modern buildings. And by default, this use environment hook will look for files with those file names inside of there. So this is the -x texture, this is the -y, and this is the +x, +y, and +z. So if we just save it like this, you'll see that this works as well. And by the way, let's remove that background only and change it to just background so that it's applied to the sphere again. And the next thing we are going to do is add a box to our scene, so that we can see if the box is reflected on our sphere. So for that, let's just add a default box from drei and give it a mesh standard material with a, let's say, red color. And we're gonna have to give it a position as well, because otherwise it's going to be on the same position. Let's just put it right there. And as you'll see, currently there is no reflection of that red box, so you don't see it at all on our sphere. Now you might be thinking, well, that's quite problematic because I want to show my own objects instead of just only an HDRI that I got from the internet. But luckily that it's possible. So drei contains a CubeCamera component, and that component, what it does is basically it sets 6 cameras in the center of our scene, and it lets those cameras make 6 pictures towards all the sides of our scene, so that in the end you have 6 textures that we use and combine into one single data texture. And we actually have access to that data texture. So instead of a normal child, this CubeCamera accepts a callback function as a child, which contains a texture parameter. Now, in here we can actually return an environment, just like we did before right here. But in this case, we can set the map to the texture that we got right here. And this will not work by default because TypeScript doesn't understand what's happening here. But it is actually valid. So what I'm going to do is ignore this, this error right here. And by now you would probably expect it to display the cube on the sphere, but it still doesn't happen. And the simple reason is that it's currently overriding this environment with the environment that we created before. We still do need this environment because that contains our actual environment map, but we should just move it before the other environment. And this will actually fix it. And now you'll see our cube inside of the sphere reflected, and it reflects correctly as well. But we should be aware that currently the CubeCamera, it is creating pictures from the center of the scene to the outside. And currently our sphere is around that center. So it is making pictures of the inside of our sphere, and that can cause some issues. So it's best to move that inside or remove that from our scene right here and move it inside of our CubeCamera callback so that it doesn't get included when the CubeCamera is recording the images. Now you might have noticed that the cube is not of the best quality, and that is actually only because of the roughness. So if we would lower that down to 0, you'll see that it looks quite sharp. Alright, so the next thing we're going to look at is animating the cube and see how that looks in our sphere. And the way I can do that is I can just rotate the box right here. But there's also a different way that might be a little bit more reusable. So I'm going to show that instead. And for that, what we're going to do is we're going to create a rotator component that we're going to wrap around our box. And basically what that will do is it's going to rotate all the meshes or objects that are inside of this rotator. So let's create one on the top. And it does need to accept children because we are passing a child inside of it. And that's going to be of type React Node. So what we have to do here is we're going to return a group. I can do like this. And inside of that group, we're going to pass the children. Excuse me. And this group needs to be referenced so that we can have access to all the children inside of the reference. So let's create the ref right here. The type group from Three.js. Let's also import the use ref hook. And now it's complaining that the group ref can be of type group, but it can also be null, even though we know that it will never be null because we specify it right here. So let's use the non-null operator right there. Now what we want to do here is we want for every child inside of this group, we want to rotate that child. We don't want to rotate the entire group because if objects are positioned on different places, then the group will rotate it based on the position of the group, which is the center of the scene by default. So that means that, for example, this cube would start to rotate around that center. And that's not what we want. We just want the cube to rotate around its own. So what we're going to do for that, well, first of all, we're going to use the use frame hook to rotate. And in there, we're going to use the children of this group ref, and it knows which children there are because we specified that right here. And for each of those, we're going to rotate it on both the X and the Y axis. And let's be safe and make sure that it is a 3D object. So there we go. And as you can see, it is rotating right there. And if we would now add another box in that same rotator, give it some different positions and another color, you'll see that it's also rotating, even though we just specified a basic box here. And as you can see, it is by default already working. So we don't have to do anything for that anymore. But I want to make you all aware that if you want to change something about that, there is a frames property right here that you can set to 1, for example. And that will only generate 1 frame at the beginning when the scene has just been loaded. And that can be useful if your scene is static. For example, it will reduce the load on your website quite a lot. But by default, it will be infinity. And therefore, it will keep running forever. Now, another way to optimize the performance is by specifying a resolution property. And this is basically the resolution of the pictures that are being created by the 6 cameras. So the higher the resolution, the more load on your computer, of course. So by default, this will be 265. And if that's enough, then definitely don't increase it. If you can lower it, that would be nice. But yeah, just to make you aware that this option is here. There are still some other options that you can set, such as the near or far value of this of the CubeCamera. But I would set the near and far of all the 6 cameras actually. And if you're not aware what that means, I recommend you to check out my video about cameras. But anyways, there are also some other options, and also in the environment component, there are still some other options. But I recommend you to check those out yourself and learn more about them on the internet, because everything is open source and you can just find it on their GitHub. And that was actually everything about environment maps for this video. So if you have any questions, then feel free to ask them down below. Don't forget to like and subscribe, and I'll see you in the next one. Ciao!